Okay, so we're moving on to Ixl level J, R.2. And the big difference with these problems is instead, whereas before we were always missing the hypotenuse, and they very nicely labeled that for us with a C, now we're always going to have the hypotenuse because we're looking for a missing leg. So in this case, what we're missing is A, which is this part of our equation. Otherwise, it's the same process. It's just that when we get into the algebra, we're going to still square the legs, but then we're going to have to square the leg we've got, but we're also squaring a hypotenuse. So here's what this looks like. In this case, A is what we don't have, so I'm going to call the A squared, just leave it A. B is 15 squared. C is 17 squared. So I don't know what A squared is yet. I'll have to find that out, but I know that 15 squared, using a calculator, is 225. And 17 squared is 289. Again, I'm not expecting that you would know this without using a calculator. Now, here's where it gets a little different. Whereas before we were adding these two together and then just taking the square root, now there's just one simple difference, and that is that instead of adding, because we've got addition already, we need to get A by itself, so we need to get rid of that 225. And the way to do that, just as we did in other equation solving we did this year, was to subtract it. So that means this cancels out. A squared is 289 minus 225, which is 64. But now here we are, just like we were in the last ones. Our final step is going to be to take the square root of both sides. Square root of A squared is A. Square root of 64 is 8. So our answer is 8. Same scenario. We'll start with our theorem. I recommend to students always to start by writing A squared plus B squared equals C squared, and then plugging in the numbers. Here we know what we're missing is B squared. So this must be A, and of course this is C. Got a little stray mark over there. All right, so 8 squared plus B squared equals, in this case, 10 squared. Using my calculator once again, I get 64 and 100. And then I have to subtract. I'm going to use a different color here. Subtract that 64. It doesn't matter if it comes first or second, it's still positive, and we're still looking at addition here. So the way to undo addition is to subtract that 64. And again, from both sides. So B squared equals 36. And I apologize for that stray mark there. My finger got in the way. So let's just go down here. B squared, take the square root of that, take the square root of 36. And when you take that, you should know, maybe you knew it already, the answer is a perfect square. It's 6. All right, now this one looks harder because the numbers are larger, but if we're using a calculator, it's really not any different than what we've already done. A squared plus B squared equals C squared. And in this case, this will be A. B is what we're missing, and this is C. So let's go ahead and plug in 48 squared plus B squared equals 60 squared. Now, I don't know what 48 squared is, but I have a calculator, so I do now know. It's 2,304. Now, I know what 60 squared is because 6 squared is 36, so 60 is just 36 with 2 more zeros. Each of these zeros gets squared too, so it's included. And again, as we've seen, we're just going to subtract in each case when we're missing a leg. I forgot the exponent there. B squared equals, let's see here, 3,600 minus 2,304 equals 1,296. Final step, let's take the square root of both sides. This is probably a perfect square because they didn't give me any instructions right in here about having to round anything. So when I take the square root of 1296, it turns out it is a perfect square. Oops, sorry, need the pen back. That means B, not B squared, B equals 36. Okay, last one, and again, this one's not going to be a perfect square. We're going to have to use our calculator, and we're going to have to round to the 10th place, which is 1 decimal place to the right of the decimal. Here's A, here's C. Start with the theorem. It'll help you keep it in your brain so you don't forget it. 4 squared, because a is what we've got here, plus b squared equals 8 squared. 16 plus b squared equals 64. And then minus 16 from each side to give me b squared. 64 minus 16 is 48. So last step is to take the square root of both sides. Square root of b squared is just b. So we do that. The square root of 48 is 6.928203, and on and on. It's an irrational number, obviously, because we're taking the square root of a number that's not a perfect square. Remember from before, that's always going to be an irrational number. But to the nearest tenth, 6.9282 ... is 6.9.